This is my stepper motor driven forklift design. It is driven by a NEMA 17 bipolar stepper motor. A stepper motor has two sets of coils, each containing two types of coils. One set contains coil types A and A0, and the other contains B and B0. They are organized like this in a repeated pattern throughout the motor. There are four ways to drive a stepper motor: wave drive, full stepping, half stepping, and micro stepping. Wave drive is the simplest way to drive a stepper motor, and it involves powering one coil pair at a time, looping through the coils and directions of current to spin the rotor. It is not used in the forklift, as the only advantage it has over full stepping is its energy efficiency. Full stepping involves powering both pairs of coils at a time, alternating the direction of the current to turn the rotor, and provides much more torque than wave drive while also being just as simple. In fact, full step drive has the most torque out of any drive technique, and so it is included in the forklift. Half stepping is like full step drive, but includes half steps between each step where only one pair of coils is powered. It has more resolution than full stepping, but less torque. Resolution refers to the smallest amount that the stepper can move. Half stepping is used in the forklift, and a single pole double throw switch is also used to change between half and full stepping. This switch also acts as a speed switch, because since half stepping has double the steps of full stepping to make a revolution, and they use the same delay time between steps, full stepping functions as a faster speed. Micro stepping is achieved by varying the amount of current passing through each coil in small increments to achieve the smallest possible rotor resolution, but also the lowest torque, max speed, and energy efficiency, due to many coils being powered different amounts at all times. It is not included in the forklift design due to being very complex and needing a much more complicated motor driver than the one I have built. The motor driver is composed of two H-bridges, which allow current to be passed through the coils in either direction by powering pairs of transistors. They also contain flyback diodes, which prevents voltage spikes caused by variations in current to an inductive load. This driver is used in tandem with an Atmega 328P microcontroller IC to drive the motor. The PCB for this design unfortunately does not work, but here is the same circuit working on a breadboard. This motor is used to drive a 3-sprocket pulley that is attached to the forks to raise them up and down. The sprockets are attached to free-spinning 3D printed axles that are spaced out along the uprights to create tension. All three of these 3D printed parts are modeled in Fusion 360.